Hi guys, welcome back to my channel. In today's video, we'll be solving problems on moment of forces, including this problem and a few more, and a few problems on resolution of forces, and end today's session. If you haven't subscribed to my channel yet, please do hit that subscribe button and turn on the notification to stay updated. Currently, I'm uploading videos on engineering concepts and planning to upload a few other concepts as well. Now get your books and let's get into it. To start with, we'll solve this problem based on moment of force. Okay, now let's take a look at the problem. Determine the angle alpha for which the moment of 500 Newton force is maximum about O. Also find magnitude of maximum moment. Now in this problem, they've given us a structure in which this structure has a fixed point O and the 500 Newton force is acting at an angle alpha. Now let's see how to solve this problem. The first step will be to find the angle alpha. The second step is to find the magnitude of the maximum moment. How to find this angle alpha is we need to first construct an imaginary line connecting the point O to point A. We need to find the angles using the cosine rule. Now this concept would be easier if you already have seen my previous videos. The link will be in the description box. Now if you had seen the previous video, you would know that the moment of a force is only obtained when the line of action of that force is perpendicular to the required point. Now in the question they have mentioned 500 Newton force is maximum about point O. For the 500 Newton force to be maximum about point O, the line of action of this force should be perpendicular to OA, right? Now let's make an imaginary line constructing the point O and A. We need to find angle alpha now. The first step will be to draw this diagram. To find alpha, we need to find this angle over here. Let's consider this angle to be theta. This we can do it by using the cosine rule. Using the angle sum property of a straight line, we can find alpha as well. Before we get into this, let me explain what is cosine rule. Now let us consider a triangle with sides A, B, C and angles alpha, beta, gamma respectively. According to the cosine rule, if you want to find any side of this triangle, this formula should be used. That is, a square is equal to b square plus c square minus 2bc cos alpha. Using this formula, you can find any side. Now this angle can vary. You can take any angle over here. You can take either alpha or beta or gamma. It gives you the same answer. Now let's see how to find the angles using the cosine rule. Now the formula will be cos of any angle, here alpha, is equal to b square plus c square minus a square by 2bc. Okay. Now I'll just give you a brief explanation of sine rule as well. The sine rule says that the ratio of all the three sides and the sine of its respective opposite angles will be equal. Okay. That is, a by sine alpha is equal to b by sine beta is equal to c by sine gamma. This formula can be used to find the sides. For finding the angles, you should take the inverse of this formula. That is, sine alpha by A is equal to sine beta by B is equal to sine gamma by C. This formula can be used for finding the angles. Now just make a note of this. It will help you a lot in the future as well. Now let's get back to the problem. Let's take OA as A and OB as B and BA as C. Let us consider beta equal to 110 degree. Okay. Applying the formula, we get a square equals to b square, that is 100 square, plus 150 square. Now remember, all of this is in mm, okay? Into 2 into 100 into 150 into cos 110. Solving this, we get a square is equals to 42760.60 mm. Remember that there's a square over here. Most of you guys might forget taking the root. Therefore, A is equal to 206.78 mm. OA equals to 206.78 mm. We have now found the distance of OA, that is 206.76 mm. By applying the sine rule, we can easily find the angle theta. OB by sine theta is equal to OA by sine B by sine beta. Here beta is equal to 110 degrees. On solving this, we get 100 by sine theta is equal to 206.76 by sine 110. On solving that, you get 220.029. On solving that, you get 100 by sine theta is equal to 220.029. And now we need to cross multiply this. On doing that, we get 100 sine theta is equal to 100 by 220.029. Finally, we get theta is equal to, we put the sign on the RHS, sine inverse. On solving this, we get 0.455. That is, theta is equal to 27.03 degrees. Now we have found theta to be 27.03 degrees. By using the angle sum property of a straight line, we can calculate alpha. On applying the angle sum property of the straight line, we get theta plus 90 plus alpha is equals to 180. On solving this, we get alpha is equal to 62.97 degrees. Next, we need to find the magnitude of the maximum moment. Moment is equal to force into perpendicular distance, that is 500 into the perpendicular distance between the force and the point is 206.76. On multiplying this, we get 103.380 Newton mm. Okay. Don't forget that you have written the distance in millimeter. Now we need to convert this into meters, as the SI unit of moment is Newton meter. To convert it into meter, we need to divide this by 1000. We get the maximum moment to be 103.38 Newton meter. So we have found the magnitude of the maximum moment and the angle alpha. Now let's move on to the next question. Now this is the second question. Find the moment of 100 kN force acting on a rigid body ABC as shown about point A. Now they have given us the 100 kN force and the angle of inclination, and they have given us the distances, and we must find the moment of this force about point A. Now let's solve this. The very first step will be to resolve the 100 kN force into x and y component. But for that, we need to first find the angle of inclination with respect to the x-axis. Now let me construct a line and let me construct an angle theta, that is with the angle with respect to the x-axis. We'll need to find theta. But how to find that? We can do that by taking the angle sum property of a straight line. We'll have to find this angle also. Now we can do this only by taking a triangle, finding the interior angle first, and after this we'll find this to be 90 degree, and we can easily find theta, and then we can find the moment. Now let's get started. Let's consider the triangle BCD, and we need to find the angle BCD. We can find this by using the angle sum property of the triangle, that is angle BCD plus angle DBC plus angle CDB will be equal to 180 degree. Now substituting the values, we get angle BCD is 45 degrees. Now we got this to be 45 degrees, and by using the angle sum property of a line, we get 45 plus 90 plus theta plus 20 is equal to 180 degree. We get theta is equal to 180 minus 155 degrees, that is theta is equal to 25 degrees. Now we found theta. The next step is to resolve the 100 kN force. Now we can observe that the 100 kN force is directly heading towards the third quadrant with the angle theta is equal to 25 degrees with respect to the x-axis. The horizontal component, that is fx, will be f cos theta, which is 100 cos 25, that is 90.63 kilonewtons, and the vertical component fy will be f sin theta, that is 42.2618 kilonewton. While you're solving the problem on moment of forces, you don't need to consider the negative sign. As it is in the third quadrant, you should actually get x is negative and y is also negative. But while solving the problems on moment of forces, there's no need to consider this negative sign. You should take it as positive. Now the negative sign comes when it is in clockwise, when the direction of the force will be in clockwise or anti-clockwise direction. There's no need to consider the negative sign while resolving the forces in this problem. But while you're solving a problem which is asking you to only find the resolved forces, then you need to consider. But while solving the moment of a force, it's not required to consider the negative sign. Okay. Now let's continue. Now I have found the x component 90.60 kilonewton and the y component of this force, which is 42.261 kilonewton. Now if you remember, in my first video I had explained about the principle of transmissibility of forces. Now we need to use the principle of transmissibility of forces in this concept. Now the force 90.63 kilonewton, you cannot rotate it in a 90 degree fashion so that it goes and meets the point A. According to the principle of transmissibility of forces, this force can be put anywhere along its line of action. So I consider it to be over here, and now you can tilt it in anti-clockwise direction such that it goes and it meets the point A. But you don't know the perpendicular distance, so you need to calculate this distance. Okay, we'll do that. And to find the moment of the force 42.261 kilonewton, again use the principle of transmissibility of forces and extend this force over here such that you can rotate it in a 90 degree fashion and it goes and it meets the point A. Okay, and again you have no idea about the perpendicular distance. For that we need to calculate this distance. Again we need to consider the triangle BCD. We can find the distance by applying sine and cos to a 45 degree angle. We get DC is equal to 70.71 mm and BD is equal to 70.71 mm. And finally we find the moment of the 100 kN force. First let us consider 90.63 kN force. The moment will be force into perpendicular distance, that is 90.63 into the perpendicular distance for this force is 70.71 plus 200 millimeter. That will give you minus 24534.4 kilonewton millimeter. Here the negative sign comes because you are rotating the force in an anti-clockwise direction, but the SI unit is kilonewton meter. Now we need to divide this by 1000 to convert it into the kilonewton meter. After you do that, we get MA is equal to minus 24.534 kilonewton meter. Now for the force 42.261 kilonewton, the distance between the point and the force is 70.71 millimeter. As you rotate it clockwise, it remains positive, and when you multiply the force and the perpendicular distance, you get 2.98 kilonewton meter. Now finally we need to add these both to find the final answer. Now on adding these two values, we get 21.55 kilonewton meter, that is in anti-clockwise direction. Now this comes to the end of this problem. Let us solve one last problem and end today's session. Now let's look at a problem on force couple system. This is a very easy concept. You'll have to compute the moment and replace the whole system by a single force. Okay, let's get into solving the problem and you'll understand it better. Now in this case, they have given us a horizontal force, but it will not be the same always. They might give you an inclined force. If they give you an inclined force, your first step will be to resolve the force into its horizontal and vertical component and then proceed with the other steps. But as of now, they have given us the horizontal force, and the next thing we will require is the perpendicular distance. Here they haven't given us the perpendicular distance, so we'll have to find the perpendicular distance by constructing a straight line and by finding its distance. So we'll have to find this distance now. And how to find that? The first thing we'll need is this angle. We compute that by taking theta is equal to, the whole angle is 90 degree. So 90 minus 60, that will give you 30 degrees. So we found theta to be 30 degrees. After this, we'll have to find this distance. We can find that by using cos theta. Cos theta is equal to base by hypotenuse. We have to find the base. So we take it as x by hypotenuse is 0.6 meters and theta is 30 degrees. On solving this, we get x is equal to 0.519 meters. Now we found this distance as 0.519. Okay, this will be step 1, this is step 2 and step 3. The third step will be to draw two equal and opposite forces at the required particular point. Okay, here we have to draw two equal and opposite forces. The force given to us is 600 newtons, so we will need to draw 600 newton forces in opposite directions. And now we couple the force. That will be step 4. This is the procedure, guys. You'll need to couple the forces now. Now to find the moment, you'll have to move the 600 newton force in a clockwise direction. Once you do that, you'll have to move this 600 newton force in an anti-clockwise direction, such that both of these forces meet and they couple each other. And you also have to find the moment with respect to point O. When you do that, the force into perpendicular distance, that is 0.519, you get minus 3.114 as it is in anti-clockwise direction. And the final step will be to write the couple and the remaining force. Remaining force is 600 and 311.4 Newton meter is the coupled force, that is in anti-clockwise direction. As it is in anti-clockwise direction, we need to represent it by using the arrow that is showing you that it is in anti-clockwise direction. Now this comes to the end of this problem and also this session. Please leave a like on the video if you have made it till here and if you have understood the concepts very well. Guys, you need to give me some feedback on how the sessions are going on so that I can improve on some places. And also do follow me on Instagram. I've left the link in the description box. You can ask me any doubts or any queries. I'll reply as fast as I can. Thank you guys for watching today's session. Do not forget to subscribe. Stay tuned for more. Bye for now. See you in the next video.